Welcome to AirNet guys. So let's check out what's our new topic today. What is air-driven generator, or called as RAM air turbine? A RAM air turbine, or RAT, is a small turbine that is connected to a hydraulic pump, or electrical generator, installed in an aircraft and used as a power source. The RAT generates power from the airstream due to the speed of the aircraft. With the exception of crop dusters, modern aircraft only use RATs in emergency. In case of the loss of both primary and auxiliary power sources, the RAT will power vital systems, flight controls, linked hydraulics, and also flight critical instrumentation. Some RATs produce only hydraulic power, which is in turn used to power electrical generators. In some early aircraft, small RATs were permanently mounted and operated a small electrical generator or fuel pump. Modern aircraft generate power in the main engines or an additional fuel burning turbine engine called an auxiliary power unit, which is often mounted in the rear of the fuselage or in the main wheel well. The RAT generates power from the airstream due to the speed of the aircraft, and if aircraft speeds are low, the RAT will produce less power. In normal conditions, the RAT is retracted into the fuselage, or wing, deploying automatically following complete loss of power. In the time between power loss and RAT deployment, batteries are used. RATs are common in military aircraft, which must be capable of surviving sudden and complete loss of power. Many modern types of commercial airliners are equipped with RATs. In the 1960s, the Vickers VC-10 was one of the first types of airliner equipped with a RAT. The Airbus A380 has the largest RAT propeller in the world at 1.63 meters in diameter, but around 80 centimeters is more common. A typical large RAT on a commercial aircraft can be capable of producing, depending on the generator, from 5 to 70 kilowatts. Propellers started as two-bladed or four-bladed models, but military, and increasingly commercial, models now use ducted multi-blade fans. Smaller, low airspeed models may generate as little as 400 watts. In other military uses, pod-fitted systems such as the M61A1 Vulcan or electronic systems, for example the IN/ALQ99 TJS, can be powered by a RAT in standard operation. Also, some freefall nuclear weapons, such as the British Yellow Sun and Blue Danube, use RATs to power radar altimeters and firing circuits. In non-military use, RATs have been used to power centrifugal pumps to pressurize the spray systems on aircraft that are used as crop dusters to deliver liquid agents to cropland. The major reason for choosing a RAT is safety. Using a RAT allows the FAA-certified engine and power systems on the aircraft to remain unmodified. There is no need to use an engine power takeoff to drive the pump, and the pump can be placed low or below the exterior of the airframe, greatly simplifying plumbing, and being the lowest point in the plumbing. It will have gravity feed from the spray tanks and never need to be primed. In the event of a pump failure that could result in seizure, there is no effect on the flying ability of the aircraft or its systems, apart from the obvious fact that the spray systems are non-functional. Why don't we install a windmill on aircraft? Why it was not suits for aircraft? Because a windmill has a lot of drag. For a windmill connected to the ground, that force is reacted into the ground. On a plane, it would need more thrust from the engines. It would take more power to drive it through the air than the power that would be extracted. Some emergency auxiliary power units for aircraft actually do use a windmill. If the engines fail, this device drops down below the belly of the plane and creates power to run the electronics and control surfaces. The airplane is gliding downhill at this point, and this lets them keep flying the plane. But its use increases the glide slope. The energy is coming from gravity, the weight of the plane descending. Thanks for watching guys. We'll come up with next topic very soon. Have a good day all.